Hello students, today we're going to be talking about reflecting points in the coordinate plane. And as we start to talk about this, you'll start to hear a few key phrases. For instance, you'll hear reflect the point over the x-axis. Or you'll hear reflect the point over the y-axis. You might even hear something like reflect the point over the y-axis and then reflect it over the x-axis. And you could hear the term reflect it over the origin. So I'm going to cover those with you today so that you can get an understanding of what exactly that means. So we're going to look at number 1 first, and you should have your graph paper. You just need to draw your simple cross. You don't need a full numbered coordinate plane because you understand that this is the basics of the 4 quadrants, okay? And so we're going to start with this one. It says reflect 3, 2 over the x-axis. So it says reflect the point 3, 2 over the x-axis. But before we can reflect anything, we have to actually graph the point 3, 2. So let's go ahead and do that. So remember, if this is always my x and this is always my y. And I always do x first. So x 3 to the right and up 2. There we go. All right, so that is 3, 2. Now, I have to reflect it, and what I want you to think about is if we folded this piece of paper right along this line, and we folded it in half, where the point would be on the other side is the reflection. It's like a mirror image, okay? This is the mirror and the image is over here, okay? So when I reflect it, I'm finding the point on the other side that matches it. So on the other side of the x. So if I'm reflecting over the x, that means I gotta jump over the x. Remember, this is the x, this is the y. Okay? So I'm jumping over the x to find my reflection. And I do that by placing it there. Now, what's the point location for my new ordered pair? Well, my new ordered pair is still 3 over, but this time it's -2. All right, so now look at those 2 ordered pairs that we worked with, 3, 2, and 3, -2. We reflected over the x. And because we reflected over the x, you're going to notice that the x's did not change. See, they're the same. So when we reflect over the x, it means that the y changed. And it changed to its opposite integer, didn't it? 2, the opposite integer for 2 is -2, right? And if I went backwards and I said the opposite integer for -2 is 1. So when we reflect over the x doesn't change, but the y changes, okay, to the opposite, all right? And I can show you that again by doing, let's say, let's look at the ordered pair. I'll use blue this time. Let's look at the ordered pair, -5, 4. Now, I automatically know that since the x isn't going to change, I could go ahead and write down that -5 And since the y is what's going to change, I can change it to -4. So let's try that. Let's see if that actually works out. Let's see if I'm right. Okay. So -5, so I'm going to the left 1, 2, 3, 4, 5, and I'm going up 4. Up 4, here I am. And now let's do this one. -5, -4. 1, 2, 3, 4, 5, down 4. 1, 2, 3, 4, right there, -4. So now when I look at my two points, they are mirrored over the X. Remember, like I said, if I had folded this paper and I held it up to the light, the two dots should be pretty much in the same spot. Okay? So that's a reflection. Let's try another. Okay, this time we're going to reflect -4, 4 over the y. Okay, so -4, 4. First, let me find -4, 4. -4 is to the left. 1, 2, 3, 4. And 4 is up. 1, 2, 3, 4. And again, remember we're doing -4, 4. And since we're crossing over the y-axis, that means we're going to cross over this axis. Remember, this is the y. Okay? Since we're crossing over the y-axis, I know that this time my y's are going to stay the same. So I could automatically go ahead and write my 4. And it's going to be my x that changes. So my x is going to be 4 because it changes to the opposite integer. And I'm going to go ahead and check and make sure that it works correctly. So I'm going over 4, and then I'm going up 4. And this time, since we jumped over the y for our reflection, remember, if I folded this paper in that direction, if I folded it that way, if I held it up to the light, my two dots would be almost in the same spot. Maybe just a little bit off from my pen mark. Okay? So that is a true reflection. It's like this is the mirror right here, and this is the point staring at itself. Okay? Now, let's try one more. Okay, so let's say I say to do, let's do 2 -3. Okay, so I'm going to go ahead and graph my 2 -3. So remember, 2 is positive, so I'm going 2 to the right on my x. And then -3, I'm going down 3. So this is my location. And then now I have to figure out my other point. Where am I reflecting it? Over the y. Remember, we're doing y's on this one. So if I'm reflecting it over the y, that means my y is not going to change. And my x is going to change to its opposite. And then that means that my point is over here. See how it's a mirror image of itself? It's even. It's weighted properly. Okay. Another way that you can begin to remember these is that notice that over here for my x's, this one, if I draw a line, and if I draw a line here, those are both vertical lines. So verticals go up and down. So that means that my y is changing. See, it's vertical. And then for these guys over here, those are horizontal lines. And if you look at my integers, they're horizontal, So that means my x is changing. And remember, this is my x line, my x-axis. Okay? Okay, so now let's get into where it could get a little bit more confusing, okay? So this problem says reflect the 4, -7 over the x-axis, then over the y-axis. Okay, so what it wants you to do is it wants you to plot twice. So first let's find 4, -7. So 4, 1, 2, 3, 4, -7, 1, 2, 3, 4, 5, 6, 7. It's a little close to my other example, but we'll deal with it. Okay? So there's my point. I'm going to move that up. Right here. And now it says to reflect it over the x. So remember, my initial point was 4, -7. And if I'm reflecting it over the x, that means my x is not going to change. And I'm going to change my y to its opposite. So it's 7. So now I'm going to go 4 and 1, 2, 3, 4, 5, 6, 7. So my reflection is right here. Okay, so here's my original. Here's my reflection. And then it says, then over the y. I'm not saying to take this over the y. I'm saying to take the original over the y. So over the x. And now we got to do over the y. Remember, if we're doing over the y, it's the y that doesn't change. We have to go back to the original. And then it's the x that changes to the opposite, -4. So now my point is here. Okay? So I had to do 3 different points for that problem. All right, next one. Okay, this one sounds weird. Reflect 2, 4 over the origin. Well, think back to where's the origin. So I'm going to use a different color so that it's not confusing. So remember, our origin is this guy right in here. That's our origin, right? That's where we start all our counting. All right, and we're reflecting 2, 4. So let's find 2, 4. So 2 is positive, so I go to the right 2. And then 4, I go up to 4. Now, if I reflect over the origin, essentially I'm reflecting over this. So I'm going diagonal. Okay? And when I'm diagonal, I am opposite on both integers. So remember, we had 2, 4. And if I change the 2 to its opposite, it's -2. And if I change the 4 to its opposite, it's -4. And so now I know if I plot -2, -4, I'm going to come over here, -2, and go down -4. And now this is a diagonal mirror opposite. It's a reflection over the origin. Okay, we'll do one more just in case that's confusing. So reflecting over the origin, let's reflect the point -4 6. -4, 6. Okay? So -4, 6. First thing we got to do is we have to graph the first point. So -4. I'm going to the left. 1, 2, 3, 4. That's my -4 line. And I'm going up 6. 1, 2, 3, 4, 5, 6 because that was positive. Okay. And now remember, I'm going to reflect it across the origin, over the origin. Okay, so that's diagonal. And so that tells me that I can change both of these to the opposite. So -4 will become 4, and 6 will become -6. So now let me go ahead and graph it and see if I'm correct. So 1, 2, 3, 4, and then I'm going down 6. 1, 2, 3, 4, 5, 6. And now if I look at these 2 points, they are reflecting each other diagonally. Okay, so that's reflecting. All right. Now we're going to get into this guy. So in addition to points, we can also reflect shapes. So we can reflect shapes over the axes or over the origin. So first, let's take a look at A. In our directions right here, it says reflect A over the x-axis. So the first thing I would want to do is find all the points for A. And just so that it is not confusing, I'm going to just remove this dot so that it's not too distracting, okay? So let's find all the points of A, okay? So if I come over to find this corner, I can see that it's 1, 2, 3, 4, 5, 6. So the x is 6. And then it's 1, 2, 3, 4. Oops, sorry. I'm finding this corner. 1, 2, 3. So it's -6, 3. Then the next corner, let's do this corner. I can see that it's going negative, so it's -1, 2, 3, 4, 5, 6, 7, 8, 9. And it is also on the 3 line. And then let's just get this one right here. 1, 2, 3, 4, 5, 6. -6. And it is 1, 2, 3, 4, 5. Oops, sorry, I lost count. 1, 2, 3, 4, 5, 6, 7. 7. Okay, so remember we said we were going to reflect over the x-axis. So if we reflect this over the x-axis, none of my x numbers are going to change. So I know that all of these are going to stay the same. These are going to change to their opposites. So it's going to become, I'll do our new numbers in green. Our new numbers are going to be -6, -3. -9, -3, and -6, -7. All right, so let's go ahead and draw it and see if it's a reflection. All right, so I'm going to -6, 1, 2, 3, 4, 5, 6, and I'm going to -3, 1, 2, 3. There's my first one. Next one, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and down to -3. There we go. And then I'm doing my last one, -6, -7. So I already know this is -6, so now I got to go down to -7. 3, 4, 5, 6, 7. And if I draw my lines, because it is a shape, so I should have my lines. Wow, look at that. It's a reflection. Remember, if that triangle was standing up and looking in the mirror, this is what it would be looking at, the opposite reflection. Okay? Okay, then the next one, it says B. Reflect B over the Y. Okay, that's easy. B over the Y. Let's get all 4 points for B. First point, -3, 1. I'm sorry, that was terrible. -1, 3. Next point, -3, 3. Next point, -1, 1, 2, 3, 4, 5, 6, 7. And then the last point, -3, 7. And this time we are reflecting over the Y. Remember, this one says to reflect over the Y. So since we're reflecting over the Y, we need to remember our Y's are not going to change. They don't change. They're going to stay the same. Okay? So now I can go ahead and write my points. I'm going to change -1 to 1, 3. -3 to 3, 3. -1 to 1, 3. I'm sorry, 7. Got in the habit of saying it. And then -3, I'm going to change to 3, 7. Those are my new points, and now I'm going to go and draw it. So, let's see. 1, 3. 1, 3. 3, 3. 3, 3. 1, 7. Remember, starting here, up to 7. And 3, 7. Starting here, here's my, sorry, I messed up. This is not my 3. This is my 3. There we go. And there's my 3. 3, 7. And then when I plot those 4 points, I have a mirror image. This time it's this way. All right, we've got one more. One more, we're going to practice one. This time we're going to reflect C over the origin. So remember, C over the origin is taking it diagonal. Okay? So C over the origin. So first let's find out what C is. So C is 1, 1. Then I have 1 up 2. Then I have 5 up 1. And then I have 1, 2, 3, 4, 5 up 2. And then remember what we said when we're crossing over the origin, we can simply change all the numbers to all their opposites, right? All the numbers to the opposites. Okay, so -1. I'm sorry, so 1 becomes -1, and 1 becomes -1. 1 becomes -1, and 2 becomes -2. 5 becomes -5, and 1 becomes -1. And then 5 becomes -5, and 2 becomes -2. So those are our new coordinates, and we're going to graph them out just to make sure that they work, okay? So -1, 1. That bad boy goes right there. Then I'm looking for -1, -2. -1, -2. Then I'm looking for -5, -1. 1, 2, 3, 4, -5, -1. And then -5, -2 goes right there. And then if I draw it, I can see that this is a perfect reflection over the origin. Okay? All right, so hopefully you kind of find doing reflection a little fun. It's an interesting way to look at things. Remember, if we reflect over the x coordinates do not change. If we reflect over the y coordinates do not change. But if we reflect over the origin, both numbers change. All right, that's our lesson for today, and you're going to go do your practice activity.